that it's so like if you have any sort of problem, not just in your coursework, but even if you have a project you're interested in, or something that you think in your own life could be solved with a little ingenuity, a little bit of tinkering, this is the space to work on it. For example, we have here a bunch of 3D printers which are available to any undergraduate, or in my case, graduate student work. So in general, how it works, we do a very simplified overview is that once you finish a design for a project, you then throw it into a slicer, for example, this one, and you slice it, and that is to say, you generate sort of the image and make a file that can be read by a 3D printer. And this in turn, you can then throw onto a 3D printer. And just if everything's working smoothly, nobody's messed with it too much, or it's sticking, you can, if all things go according to plan, then it'll start printing slowly, it should. So when this is done, this is an example of a project from one of our senior undergrads. This will be a replica of the Alberta concert. However, like the 3D prints don't always simply go to plan, as evidenced by this one right here. This is what happens when a 3D print does not stick to the board. So as you can kind of see, like the plastic just kind of built up and it gunked up the works, and I came in here and I had to melt off chunks of it with plastic, so without heat guns. So that was a fun time.
I just threw in this printer that actually built this replica so that they could study the acoustics of the Royal Albert Hall in one of their experiments. Oh, there's a question.
Okay, so we have a question from one of our attendees. What do you make with the 3D printer?
Well, you can make a lot of stuff. Well, 3D printing is kind of interesting because you can make basically anything that you can make out of plastic, you can make with a 3D printer. So, and there's even been some more experimental type of 3D printers for industry that I've even seen stuff where they print using metal alloys, like so you can design rockets that way. Like, it's really interesting. I forget the name of the company, but in my case, my own work specifically for just using the basic 3D printers here, I actually made a nice little component for my own setup. Because one of the issues I was having in my own research was, just for a bit of context, I work in plasma physics, and one of the things I'm studying is laser-produced plasma films. And the problem with laser-produced plasma films is they're incredibly short-lived. So to kind of keep them going, it's like you kind of have to throw logs onto a fire. You kind of need to give it a fresh surface every time. So what I was doing before was I was actually like just hand turning a crank to just sort of give it a fresh surface. But then I kind of was playing around with some different ideas, and one of the things I finally realized is I had a lot of these random motors just sort of sitting around in the lab. Like this one was kind of busted. And so what I decided to kind of experiment with was I was like, okay, well, I could just design something that can just fit onto this metal ring right here, and then use like sort of a like I was going to be a blade of copper to produce the plasma. So I just slapped, the idea was I would just slap it on here, turn this on, and then just let it spin, and maybe I can get it running. So, and it fits, and that's just with the friction. But like the idea was that every time that this thing would turn, it would provide a fresh surface for laser. So that's one example of just one tiny thing you can build with a 3D printer. Very, very simple.
Yeah. There's another question here. What is the biggest item you have made with a 3D printer?
That over there. Still a work in progress, but this is the frame for a 3D printed microscope, or part of it. It's still being assembled. That would probably be one of the larger things I've made. So yeah.
And this item here, this really highlights one of the advantages of 3D prints is they can make complex parts that you can't make with ordinary machining, or if you were using ordinary machining, you'd have to make, in this case, hundreds of different parts and then assemble them all. Whereas that complex structure here can be made, most of it, in just one continuous print in the 3D printer, because it builds up the structure by adding material instead of starting with a solid block of metal and removing material.
Just one final question. What is the difference between 3D printing and 4D printing?
4D printing? Well, if you want to be really technical, it's all 3D printing is 4D printing in the sense of you have 3 spatial dimensions and you're also moving in time. So, there's no difference.
Thank you.
Yeah.
Oh, just one more question as well. Can you use other materials, or is 3D printing like metal?
You can. Well, for the 3D printing that we do here is primarily plastics based, and then there is like more experimental 3D printers that exist in industry or manufacturing that focus on that do use metal or some alloy of metal, like some sort of various alloys of metal. I wish I could know the name of the company that works on it, but I think they partner with SpaceX on certain design as well, designing rockets. But one of the problems in sort of, at least in aerospace, is just when you're building the hulls for these rockets or planes or whatever, it's like very intricate, requires a lot of machines, a lot of staff on hand. So they were kind of thinking of using 3D printers as a way of cutting costs. So yeah, it's like, the thing is that what you see here in the shack is the beginnings of an emerging sort of manufacturing technology.
And can you make a Lego with a 3D printer, or have you made a Lego with a 3D printer?
I personally haven't, but you could do a lot. You could do a lot of. I don't think there's anything forbidding for a 3D printer. Like, if you want to come over here, there's like this might not exactly be a Lego, but you can make nice little intricate parts that work together, like as in this print made by a student. And there's even some bits that are just interweaving this. And basically anything that's like that has a screw, a thread, or a hole. It's possible to design. So hope that answers his question. Her question.
How do you change the color of the printing?
Oh, that's interesting. This is where you get into stuff like multi-material units, where you can't. To be honest, I don't know the full details of a multi-material unit, but the general working theory of it, my general working understanding of it is basically you have each of these like little tubes right here, they can feed a different print color, and then where you want the colors to appear, it depends on how you configure the style file.
I believe on the table over there, are those the things you have 3D printed?
They're not my stuff that I printed. I printed these two things largely as a sort of a test or calibration of these printers, just to see how well they behaved and what was the limit of their resolution. But everything here is built by built by students or various participants in the shack. So these aren't mine. I wish I could claim them as mine, but I can't.
These are models that have collected over the years.
Yeah.
And they're like craters from the surface of Mars.
Yeah.
And there are skulls that biologists have come in and printed models of. These funky things there that sort of look like screws that have been stretched or melted or something. These are actually models of gravitational radiation that some astrophysicists printed. So these are related to the discoveries of the Laser Interferometric Gravitational Wave Observatory that famously discovered colliding black holes and neutron stars, and yeah, these are kind of physical embodiments of the way the signals come out when these things when two black holes collide way out in space and make one larger black hole. So yeah, all kinds of unexpected and fascinating things happen in here.
What materials do 3D printers print?
I think, yeah, Aaron already kind of went over that a bit. There are more and more materials that they print with every passing week, basically. In addition to the plastics that we print here, and Aaron mentioned these printers that can print metal parts now, people are trying to use 3D printers to print biological materials, to print artificial organs, to print food, almost like the replicators from science fiction and whatnot. So it's definitely a moving target, but really more and more things every year.
And what are you printing currently with this 3D printer?
Replica of the Royal Alberta Conservatory, so it's a concert hall. And the idea, this was a project by one of our senior undergrads so that they could study the acoustics of the building, compare it against the London Conservatory.
And what are the parts of the printer?
Well, there's there's a bunch of different parts, but the main ones that matter is you have two motors. The Y stage motor right here, DC motor right here, that moves it up and down, and then this has to work in sync with the XZ motor in this plane right here. And the other, well, actually there's three. Never mind. There's also an X motor right there for the extra stage. But the point is that there's also a tube that goes in and feeds material into the printhead. So this whole device right here is the printhead. And then right here is the fan. And the fan in the printhead is what does the actual printing. But then there's other parts that go into it, like this little, if you can see this tiny little screw with the little black rubber at the bottom. That is the induction sensor. The induction sensor tells the computer right here, this module, roughly how far it is away from the board. And if it gets too close, it tells it to back off. Because one of the things you don't want is you don't want the nozzle scraping the print bed, which is what this is. So if that happens, you damage the print bed. You're probably going to not get a nice print, and you'll end up with that over there. So.
And how long will it take to finish that?
This print right here, it's going to take about 15 hours and 37 minutes to print this. And more generally, print times are affected by, well, there's a bunch of different factors. Like you can have the same, for example, these are the same print, but both have different settings. This one I was doing very quickly, and so as a result, it has a very coarse surface. So this one took about 30 minutes, this one took about an hour. And what determines these settings? Well, it depends on how much detail do you want, how much precision do you need, what are your tolerances? And so this is tolerances, and that's in the end what determines how long it takes to print it. And also is the size of it. what material you're making out of, like what type of plastic you're using. Like these can all have that effects. So, general rule of thumb: the bigger, more detailed prints require way longer time scales. I've seen prints that take up to like 2 days to finish, like 2 to 3 days even. So it all depends on like what you're trying to build, what's your tolerance for error in it.
What's the longest time you've taken on a printing job?
Longest print I had was like actually that the sort of the components for microscope over there. This took me. This was a 24-hour print, so I basically set it and I just let it run overnight. So that was probably the longest print I've.
Can you have more than one color in a project?
Yes, you can, but you need a different material. You need a different unit for that, which is what this printer is for, which is the multi-material unit. So these 1, 2, 3, 4, you can ideally, when this was functional, you could swap out different filament colors, and it will, and depending on the style file, it will print them in the order that you want to put it in. So it is possible to swap between colors in 3D printing. I've seen examples of it, but I personally haven't done it because it's really more complicated. It's feasible.
Here's another great question. Do 3D printers work almost the same as a 3D doodler pen?
No.
And then could you 3D print things in different materials?
That I actually don't know. Mark, do you have anything to say to that?
So the question was, could you 3D print things in different materials?
Yes. Yeah, the variety of materials.
Like this, do they mean like printing like different materials in the same print? Because you can print with different materials, but like I was just kind of curious if they make different materials in the same print. Does they mean, so can you swap between materials in print? Or is
not radically different materials.
Yeah.
At least not with these printers.
Yeah.
Who was the first person in the world to discover 3D printing?
All right, that's curveball. Yeah.
I think it goes back to the 1980s.
Huh.
People recognized the possibility quite a long time ago. What's new in the last 10 years or so is the widespread availability. And that's changed, quickly, even since we've had the Shack. I mean, just to kind of get a sense of how accessible it is. The big printers over there, behind the toolbox. So those were actually made in Edmonton by a company, Machina. And those in around 2015, was unfortunately Machina doesn't exist anymore, partly on account of the pandemic. But those are really nice machines designed and built in Edmonton, and they were about $4,000 each. And then, in the meanwhile, these Prusa printers that are kind of our mainstays now, they're made in the Czech Republic, and they cost about 1/3, around $1,400 or $1,500, about a third of what the machines cost. And this one here is kind of 6 days being repaired now. This only costs just over $500. So they're coming down in price rapidly. So that's really the difference. Back in the 1980s, it would have cost several $1 million probably to get a unit like this, and even 20 years ago, probably $100,000. It's just come down where now they're extremely affordable, and that's kind of part of the theme here as well. Just in terms of not only the models and the instruments that you can make with 3D printing, once you have the printer, the only cost is the plastic, really, which is not that expensive at all. It's about $30 for a kilogram from school of nice plastic. Actually, something that I forgot when the person was asking about the things that you can print. You can also print electronic materials. So this is a little circuit board printer that was made by a company that came out of the University of Waterloo called Volterra. So it's another Canadian company, and it lets you print basic circuit boards. And speaking of circuit boards, so this is actually one of our favorite times of the year in the shack, because it's at the end of the winter semester. Students in some of our courses have opportunities to define their own experiments, and then sometimes that will require items from the shack. And so we're gathering some of the things for experiments that start next week in this thread here. Maybe I can start over there. So one of them is an experiment where the students work with microwaves, and they can do essentially radar. If people have heard of radar, that's the radio detection and ranging that was developed during the Second World War. But this now, there's a little circuit board here that costs only $2, and it emits and detects microwaves and basically lets you do radar, and then lets you do experiments on materials with microwaves. And so here, if I turn it on, actually, maybe I should leave it off first. So, you look at, this is an oscilloscope here that shows traces that give signals. We're measuring voltages here, voltages versus time. There's nothing happening because the radar unit is turned off right now. But if I supply, thanks, Aaron, the voltage here now, and if we can look at, now I'm going to, off this brass disc, I'm going to reflect microwaves back at the little radar unit, and then you can see the signals that come from the microwaves being reflected back at the radar unit here as I move, and the speed of those signals, the rate at which they go back and forth changes too with how fast I'm moving the brass disc. And this is also this is the reason why it only costs $2 is because they're everywhere now. They're in all the new vehicles that are made. They're part of the technology that lets cars, know where other cars are. And of course, they're in the radar that the police use to monitor people's speeds, and they're in motion detectors that turn on the lights on your doorstep. And but it's really sophisticated. It's really sophisticated kind of physics hardware that can also be used by students in labs. So that's that's one of the things that we'd like to facilitate with the shack. We can put things like that in students' hands for almost no cost. And another thing with light, there's also, I guess this is turning a little bit into a plug for Canadian companies. So there's a neat company in Ottawa that's called Light Machinery, and they make really nice things that let you do things that are sort of similar to what's happening there with the microwaves, but with light that you can see. And this might be a challenge for your camera, but I'm going to turn the lights off in the room, I guess. First I'll turn, this is just a neon lamp here. Sure. I think we have to reach down right here for this one. Okay. And so this is a neon lamp, which you still see sometimes, open sign for stores and whatnot. And there's a whole bunch of colors there that just blend to this sort of orangey red just to your eye, but with one of the really neat tools from Light Machinery. So I'm not sure this will work with your camera, but we can try. If you bring your camera up to the middle there, you might be able to see a whole bunch of nested circles that are separating out the colors. Is that going to work? Might have to go sort of straight at it if that's possible. Maybe if you tipped you tip it so that the camera would be going like straight in. It might be easy. Yeah, I don't know. Can I try? Just. Oh, this thing is a robot. Oh, darn, this thing is so smart. Where is the camera? Circles. Can you see the different colors? Maybe can you see with your eye? Sorry about this, people. We hadn't tested this before with the camera. Maybe some other participants, if you can look through, it'd be good at least for someone to confirm that I'm not making it up, and then you can see different colored circles nested in there.
Yes. I see some purple.
Okay.
And blue.
Yeah, yeah.
I just have a question
Sure.
for one of the attendees. What is the red light?
Here?
Yes.
Yeah, so this is, that tube has neon gas in it. So that's one of the inert elements on the edge of the periodic table. It doesn't really react with anything. And so it just, if you collect it and put it in a tube just as the neon gas, then there are electrodes on either side that let you put a voltage across this tube. They're similar to these, in a way, to these lamps that are creating the light in our room here. If you put enough voltage on there, that electric current can flow from one end to the other through here. And in that process, it involves knocking electrons off of these neon atoms. And then things kind of happen inside the neon atom that when the electrons come back to where they started, they can lose energy in the form of emitting light that we can see. And it actually, that whole process emits extremely pure colors that we can't really tell with our eye colors accurately in a sense. But this Light Machinery tool here lets you separate the colors into their different parts, the oranges and the purples and the blues, and greens, and also to identify how pure the colors are.
And we're back to some questions about the 3D printers.
Okay.
So someone's asking, is there a job where you can work directly with 3D printers?
I mean, there's mine, which I have right now, which is just a current TA, the Shack TA as a technician. But beyond academia, and there is a world beyond it, trust me. There are companies that do hire technicians and staff to man and maintain use of 3D printers. And even if your job description is not necessarily a technician, I have friends of mine, mechanical engineering, who, for example, use 3D printers all the time for their work, like all the time for their work. they just need something. And one of them, and even people in like biological sciences, which you wouldn't think of as 3D printers, are sometimes used 3D printers to make components for experiments they want to design and the like. So there's a lot of people like you wouldn't think at first glance as being involved in 3D printers, but inevitably like, they kind of come to 3D printing because it offers one of the things that it has a huge advantage over fundamentally is rapid prototyping. And what rapid prototyping means is you can constantly iterate on your design really quickly. So you can go from an idea you have on paper to final product or near or closer to a final product really quickly. So it helps you hammer things in a lot of ways that if you just send it to a machinist, it might take you, a week or two to get back, and then only you discover, oh wait, the thread size is wrong. Oh, it doesn't actually totally fit with what you need. So to answer in summary, there's a lot of anybody who's technicians will use 3D printers or somehow it's directly related to maintaining and using them. Anybody who's involved with mechanical design, whether that's a technologist, engineer, or hell, even scientists like me will use them. So it's and there are companies whose whole thing is just repairing and maintaining 3D printers. Like we had to send 2 of our own 3D printers to riprap warehouses. Their whole thing is like selling and maintaining and fixing, distributing 3D printers. That's it. So.
I have a question asking, what was the longest print, I'm guessing, ever?
Longest print ever? I don't know that off the top of my head. But these prints can stretch out for long periods of time, much you want. Sometimes you need to print stuff in different stages, so you can't print all the material components all at once. You need to start with one step. Print the others. So.
There are different sizes of prints too, quite dramatic. There is a printer in a facility called the NanoFab here, over at the Electrical and Computer Engineering Research Facility that can 3D print things down to a scale that's about 1/100th of the diameter of a hair, like really, really tiny. And then at the other end, I know there have been 3D printed houses, right?
Yes.
I think I heard once even of 3D printed apartment buildings or something. So these things now also come on a ridiculous range of size scales, where the ones that are here are somewhere just in the middle.
It's still stuff you can still see the layer with your eyes.
Yeah.
As opposed to the one that they have.
What happens if a 3D printer overheats?
Well, that depends. I mean, a number of things that can happen. One, you fry your circuitry, and you then have a broken printer. Things. Ideally, for a good 3D printer, it triggers an overheating warning and it stops the print. So, for example, Prussia's have that safeguard in place to just stop overheating, stop it from overheating. So if the fan, for example, is jammed or stops working, there are sensors that will pick up on it and then immediately, or it sees a certain temperature, it'll shut down. So it's kind of annoying when that happens because it stops the print and you kind of have to finagle it a bit. But it's better than the alternative, which is you don't have to print it.
What are some of the names of the different 3D printers, or are they all the same?
Actually, like some of the names is in like brand or the brand. Well, there are different companies that make different 3D printers. The one I'm the most familiar with is the Prussias, which are probably the most widely used and consumer. There's a large sort of community based around them. So if you go online and look at best 3D printers, Prussia's probably going to be the ones that come up. But that's not the only type of 3D printers. There's the Machina printers, the Mark was talking about earlier. There's also Creality, which is a company based out of China that also makes 3D printers that are more consumer friendly, in that you don't have, whereas with Prussia's you kind of have to do a lot more assembling. The idea of like Creality printers is that they work right out of the box. Insert a lot of citation asterisks here, like exception cases, but normally that's what their goal is. So we're not all the same. But the operating principle is just designs change.
Okay, another question is, what is 3D printing?
Do you have a good definition, Mark?
Yeah. Well, maybe we can start with what it's not. So traditionally, when you would make things, you would start with a block of metal, and then if you would use maybe a drill bit, some sharp piece of harder metal, it would let you make holes. You can cut trenches like this with something that's a little more sophisticated than a drill press. So this is a drill press where we drill holes. This is called a milling machine, where we put something in like a drill bit, but then it's hard enough that it will keep cutting if we push the material past this spinning bit. And we could cut trenches like that. There are lathes. We have a small one currently being repaired in the other room where you put the piece of metal in a holder called a chuck, and then it spins, and then you come in with a sharp tool, and you can then remove metal by having that thing spin against the sharp tool. I mean, those are 1,000 years old. There are lathes, models of lathes that the Vikings used at like Asso Meadow on the northern peninsula of Newfoundland, for instance. So people were doing that in wood and bone and things for a very long time, and also in metal for hundreds of years. So again, this is what we now call subtractive machining, where you start with a big block of material and then you remove it until you have, sort of like doing a sculpture, until you have the shape that you want at the end. A 3D printer is what's called additive machining or additive manufacturing, where you start with nothing. You start with the raw material. In our printers, it's in a spool. Aran probably showed that. It's like a wire of plastic that gets fed into what's called hot end, and then it melts, and then you can push a bit of the melted plastic onto something and it will stick. Here comes Aran with a spool. And then what you do is you build up layer by layer the structure that you want, starting from nothing. So you're adding pieces, adding tiny, tiny little pieces of plastic in this case, until you have the finished structure that you want. And that's not the only way. There's also a quite accessible and quite accurate form of 3D printing now called stereolithography, where instead of starting with the material in a spool form here, like hard plastic that gets melted, you start with a resin, a liquid resin, and then you can, with laser light, for instance, you can, or ultraviolet provided in some form, you can cure that resin, turn it from liquid into solid in a very, very small volume. And again, build up layer by layer of the final structure by turning essentially liquid plastic into solid plastic in a big bath of this liquid plastic using light. And that's actually kind of the basis of the printers that make metal parts also. They start with a powder of metal, and they use lasers to do something called sintering, to turn the loose, very fine powder of metal into a solid piece.
I think we only have time for a couple more questions. So, is there a strong odor when it's printing?
Quite strong odor, as in
like a strong smell?
I haven't noticed it, but then again, my smell.
So if there's a strong odor, then if you have your own 3D printer and you smell some strong odor, then turn your printer off. You know, you're probably so we have for all of these machines, there are materials that are safe to use, and then there are other materials that aren't safe to use. Really, the only strong odors we've ever had in the shack have come when people are using this tool back here. So this is called a laser cutter, and so this is another thing that's more like the milling machine in the back than like a 3D printer. But instead of using a sharp metal tool to cut here, it uses a focused laser beam to cut. And there have been a couple of cases here where, one case of a plastic that went in that really shouldn't be cut with the laser, and it took many days for the smell to go away. Even though we have another thing that we're so grateful for in the shack here is the Faculty of Science did some renovations, and they put in this amazing ventilation for us to make it safe. These big yellow and with the black elbows, those are called exhaust snorkels, and we have kind of we have a big filter system here for the laser cutter on its own, and so the fumes coming out of here get filtered in this box, but then they also get sucked away in our great exhaust snorkel. And then the other one unfortunate thing that happened here in terms of odors was someone came in once and cut a bunch of wood in here. We don't let, there are a lot of interesting things that you can do with laser engraving in wood, which has also been something that's been around for many decades. But unfortunately, when that wood project was going on, the filter actually plugged because there was so much stuff coming out of the wood. And my office is on the 3rd floor of this building. We're in the basement here, and I could smell it up in the hallway outside my office. The wood. So we don't cut wood on here in the shack, but.
All right, thank you for the tour as well as thank you for all the attendees. Do you have any final remarks that you'd like to make before?
Well, I hope you can come and visit us in person sometime.
Same.
All right, thank you.
Sure, thank you.